I've asked, seems like just a few of us. Steve let me know that he's traveling, so he won't be able to make it today. But I guess few others are missing as well. But any Arto, Yuri, anything new that you folks tried or looked at?
Not much on my side. I just did like a first submission with a single model, like trained on the whole images. I just used ResNet 50 to like make a baseline to compare with like modifications I will be doing, and it had like score 70 something. So
Is
given
it
that it
ResNet
was
or
trained on those,
Nest?
excuse me.
Is it ResNet NET or ResNest NEST?
It's ResNet, simple, basic, old ResNet 18. So the minimal
Okay.
network you can use like reasonably. And yeah, so I'm still using this full images, not cropping or like splitting or something. So I was thinking at looking into normalizer free nets, because when moving to a larger network, I would have to either like crop these images or like decrease the batch size. And most of the networks rely heavily on batch norm, and you need to have a batch like of reasonable size to get the running batch statistics for batch norm, right? And but there are those normalizer free nets which do not use any normalization. So I was thinking if I could use those for my experiments on the full images, but I haven't got to that yet. Just some thoughts, and I'm playing a bit with this approach, like which would be more similar to like object detection. I mean, when you like feed the whole image, but you do multiple you like create multiple labels, and it's not doing better than it was then just like this vanilla approach I used for baseline, but I haven't really like tried all the things I want to try. I just today revisited this YOLO papers and trying to find some useful ideas there. Like basically, I remember that it works better when you like have this objectness like label, and you don't use. So if the networks predict that there is no object on on certain area, then you don't use this binary cross entropy loss on all the outputs of the network. You just train when like. So basically, it should either predict there is something, and then you like try to figure out what that is, or if network predicts that there is nothing, it just need to predict that there is nothing, and we don't care that we don't want it to predict there is no category 1, there is no category 2, and so on. So that's like makes training like more stable, I guess, or better from what I've heard, and I think I need to at least do that for a start to make it like work better. And also I need to make Meetup work with this approach, and it doesn't seem to work like out of the box because
Yeah, I was going to ask you, Arto, whether you used Meetup as part of your baseline capability.
Yeah, I've used Meetup, and that's basically the only data augmentation I'm using. And it seems like it works, and there is like only like this Meetup coefficient of 0.1. And I think I've tried with 0.3, and the score, like the validation score, was much worse, like around 10% or something. So I haven't submitted that version to like check how would it perform on the leaderboard, but I guess like the same pattern was observed in that like weights and biases report with hyperparameter search we saw in one of the early sessions. He also had, like, he tried all the values for Meetup, and ended up like having much better score when using just a bit of Meetup, I would say. And yeah, and I think it's just really useful to mitigate the overfitting problem, and yeah, so I think that would be like one of their first steps I want to try to do with that approach I'm trying now to add the Meetup. So that's basically all I've got. And how about you? Have you been able to improve your score?
Yeah, so let me share what I did. Again, I didn't, except for one particular thing, I didn't substantially investigate quote unquote new methods. I was, or at least I was trying to enhance the base infrastructure I had to try different things. So let me share my screen and let me know when you can see it.
Yep, can see.
Yeah, so I think I shared a bunch of this stuff, and I think you also saw that strangely enough, the originator of the RESTnet apparently posted the model somewhere where there is some limitation on the number of accesses. So I suddenly ran into problems of using RESTnest, which was giving me my best results. So earlier, I think I shared last week some of the kind of ablation things I tried, and especially with respect to Adam, and concluded I think that Adam gave me the best results, and Arto, as you pointed out, there was overfitting, which is why when I tried to modify the head and add a little more complexity, that didn't really help because I added a whole bunch of parameters, but not really improving things. And same when I tried for like 40 epochs, whereas my baseline was 20 epochs with the RESTnet. So that's where I ended up last week, which is about at 0.86. And, before I kind of dramatically changed things or introduced a lot of new complexity or techniques, I wanted to see how far I could push this. Unfortunately, I lost ResNet, but anyway, I wanted to try a different network. And as part of the, the reference that you spoke about as well, the weights and biases report guy, he had pointed to DenseNet 161 along with ResNet as giving in good results. So I switched to that. And as you can see, that pretty much almost matched my, not quite at the third decimal, ResNet is still better. But on the public, and the right-hand side score is the public score, this is the private score. You can see that it actually gives slightly, the third decimal digit is slightly better. And here it's about the same, except in the third decimal. It's third decimal ResNet is better, 0.867 versus 864. But given a ResNet, and Steve pointed out, thankfully, that I think another depository has ResNet, so I'll switch to that and try things. But here's where I switched and I got almost the same result, which is kind of interesting that, ResNet and the denseness seem to be about on par, maybe slightly inferior, but not much.
Is DenseNet much larger?
This is, denseness. Well, sorry, what were you saying?
I was asking if DenseNet 161 is larger.
Much larger network. Yes, that's what, because ResNet is ResNet 50. This is DenseNet 161. Okay. I also wanted to try 121, but didn't get to it as I kind of took slightly different route. Sorry, you were about to say something?
No. Yeah. Well, I have to say something. I know that recently Hugging Face included a couple of vision transformers. So it would be interesting to try replacing ConvNets with vision transformers and see if it performs similarly. So what I think about it, that spectrograms, they are not so well structured as compared to natural images, right? And it would be interesting to see how that so what I'm trying to say is that ConvNets, they rely on this local structure a lot, right? But the transformers, they do not rely on local structure as much, right? Because you just encode the image in some way, divide it into patches, encode it in some way, and then you just attend globally. So yeah, and I saw some good results with some kind of audio transformer, but they didn't release any pre-trained models. So I don't know, training that would be really too much for this competition, but maybe just image transformers pre-trained on ImageNet would perform well. So
yeah, that's something worth trying.
Sorry, have you seen any visual transformers on other sort of dirty imagery or not pictures imagery?
No, I really don't have any experience with images. So from my personal experience, I haven't interacted with vision transformers. So I'm just curious. I don't have really any insight to share about it.
But you think they should work better on images that Do not rely on like very clean structured objects. Possible.
Yeah, that's just kind of hypothesis from me because like I saw that audio, some like application of transformer to audio, and they had some good results, and also yeah, also I'm just thinking about this structure of our data, and that we are essentially using like convnets pre-trained on completely different data, right? But we still are getting good results. So that's like a bit puzzling and interesting.
Yeah, I think where the comment you made is intriguing. The first thing, which is the spectrograms not having the same kind of local structure. I would put it as not having the same kind of local structure that typically natural images, or I wouldn't say typically, that natural images may be more likely to have, or are more likely to have, which is, if you go through whatever the analysis paper, I forget the name of the paper as to what it's learning the curls and the different orientations of lines, and spectrograms mostly seem to have, horizontal lines all stuck together or not, and then it's a color variation that matters as well, right? Which that's where it's kind of intriguing, as you say, as to things trained on ImageNet, but then ImageNet has a wide variety of colors too, which, while we're at it, since almost 3 of us set in this deep learning PyTorch thing, it's also fascinating to me that color seems to send or hold more knowledge about the image than what we think in terms of representation, because one of the papers that one of the techniques in self-supervised learning is this coloring versus not colored, and then that seems to be able to learn something fundamental about the image as well, which I find fascinating. Which I wouldn't have guessed that color holds as much information as those papers suggest about. So yeah, I think, and your comment about transformers learning something global is also true. So I think that would be a fascinating thing to try. I'll definitely see whether there's some.
Yeah, I agree that as you said, the local structure of spectrograms is quite specific. Not like that they don't have it, but it's quite different from what we observe in natural images. And another approach I saw, it was using two kind of networks. So one was operating on spectrograms, and another one was operating on features from raw audio, and that was trained jointly. And I think it was I was just checking the state of the art on some of the popular data sets, like benchmark data sets, which is I think similar to what we're dealing with. Some you got to detect some sounds in the audio, so you get to identify the sources of sound, and that was probably that ES50 or I don't know how it's called.
Yeah, the same thing that the guy used, ESP50 or that the guy used, right?
Yeah, and so one of the best approaches was using kind of this features extracted both from spectrogram and from raw audio, and yeah, that's also another interesting way to go. And as I was mentioning in the, like when we started this competition, that actually in speech to text, this WAV2WAC network, which is I think one of the most like accurate right now. It also it uses like a convolutional feature extractor as the first part, and then it has a transformer on top of it. So basically, I don't know, maybe like with really big networks, you can actually get away without using spectrograms at all, maybe. I don't know. So basically the network might be able to learn to like extract something like spectrogram internally, or I don't know. Okay, so I see you got some much higher scores here. So what was that?
Yeah, so then the thing I tried, what I noticed, I mean, kind of orthogonal to that. So I switched to DenseNet because I had problems, as I said, with ResNest, which now that there's a path forward, I'll go back to ResNest and see whether I can improve these. But so switch to DenseNet, about the same score. Then I realized when I was running that it, since we're talking about spectrograms and stuff, that actually it used a top dB limit of 80 when you generate the after you've generated the spectrogram and or when you're creating the MEL spectrograms, it used a top dB of 80. So I kind of said, do I really need that? What if I don't limit that? But and I got like an improvement on the third decimal digit, but this is more an accident of some of the random augmentations I'm doing. And later on, I found out because the default is top dB of 80. So the fact that I removed it didn't actually have an impact, but I still saw an impact. So that's where we have to kind of be careful, because obviously I do random augmentations at a time, and it's not I don't believe it is seeded and stuff, so it's not always the same things. So there's a little bit of noise in this, why this increased slightly above that. So it wasn't meaningful. But one of the things that, again, what you had pointed to the thing that the guy, the hyperparameter weights and biases sweep guy had pointed to was, talking of windows, is obviously until this point I was doing 10-second windows around the true positive. And he had indicated that, hey, if you did smaller windows, it seems to give better results. So I switched from 10-second window, which is this guy here, to a 5-second window. And you can see that caused my score to jump. So that's what accounts for this difference between these two. Ignore the no top dB. That's just noise. So
that's kind of you moving on this time frequency trade-off curve, right? Because like when you like squash the window, you get less resolution or like less information in frequency space, right?
In that, yes. So there is that, but in this case, it helps, I think, because kind of, and obviously during test, then I choose 5-second window and do the same thing. So, by the way, which another variation that I haven't tried yet is I don't think just because I do a 5-second train that I need to stick to a 5-second on the test. But here I do, and this thing improved.
Maybe
now
that makes sense. Like you do the max pooling, right? You
Correct.
get the highest value, and when doing more windows, basically you pool over more values, and maybe that only that has some positive impact, right?
Yeah. So that was this, but I could potentially stick to 5-second training and even more on the test stuff and see what it does. But this is what I got. Then one of the things I again noticed, which is this is where knowledge of the soundscape and the spectrograms, I guess, would be interesting to explain this difference. But what I was noticing was what the basic reference thing does is it plots the log of the power. And that means, one of the options you can give when you convert audio to spectrograms is give a value of a variable called power, which is 2 if your output you want is that is the color intensity you want is of power, and if you give it a power value which is of 1, then the color plotted on a spectrogram is that of amplitude. So I said, well, I'm just curious, if I changed from a power plot to an amplitude plot and use that in the spectrogram, does that change anything? And lo and behold, it did change and improve my score. So the change between this guy and where I say amplitude densenet is here when I create a spectrogram, I'm creating a power spectrogram by saying power equals 2, which is plotting the power in the log power as part of the color map. Here the color map is a log amplitude plot. Okay, so that again caused things to bump up somewhat. Right?
And the private leaderboard, so it looks like it's more like smooth. So the private leaderboard score differs less from the public one here, and it's much higher.
If it's log of power of log of amplitude, aren't they the same, basically differ by multiple of 2? Right, like power is the amplitude squared.
Right of the yes, but this is where it kind of relates to the stuff that they are related, but how they show up in a spectrogram, I don't know, right? And whether the detection of the patterns in the spectrogram when it is plotted as power is different or easier recognized by the network than a plot of amplitude.
But you mentioned so I understand that would make sense if you actually use power like a color or like a intensity would be proportional to power or amplitude. But if you're using log, then they should be linear, right?
Yes, but the log is when it gets converted to the MEL stuff as part of the equations, then you eventually the color that is plotted is the log of the power or the log of the amplitude in a spectrogram. In any case, it's just that when you generate a spectrogram, you can give it a power option, which you, by specifying power is 2, or you can specify an amplitude option, power is 1. But actually, interestingly, it's a floating point. It's not a discrete integer spec. So you could potentially even do power is 1.5, and somewhere in the discussions, which, the power variable is 1.5, which doesn't correspond to anything per se, neither amplitude nor power. And somebody had used it, and the guy had asked, why did you choose 1.5 and what does it mean? And the guy said, well, it just looked nice and gave me the best result. So it seems, that conversion of does amplitude give you a best, or does the plot, color intensity plot of amplitude, is that give you best results, or color intensity plot of power give you the best result? Is not, seems to vary. And that's something that I, as I was saying, a little more understanding of it from the sound standpoint, or what causes that result to bump up, I can't quite explain.
Okay, thank you.
I can just say that, this network seems to be able to recognize, and that's why I was curious if it is restless, do I see the same, not same in terms of number, but do I see the trend line to be the same or not when I plot a power spectrogram versus an amplitude spectrogram and use the network to recognize it. So I can, I'll probably run that experiment just to satisfy my curiosity. And then to what Arto just mentioned previously, and again, driven by, what the guy had done in terms of variation and stuff, here, and I'm talking from memory, my FFT length was 2048 in this guy, the basic 8.9 that I had. So this was on any of these. So FFT, NFFT was 2048, which is, kind of the chunk that I use to do the STFT and so on. And the hop size is about 512. Now, you could potentially increase this. And in fact, the guy talks about, I think, again, I'm talking from memory, but FFT of NFFT of 4K or 4096 gave him better results. So again, that was another change. So, keeping 5-second windows, keeping the amplitude rather than the power, keeping the network this, I changed and keeping the hop size the same, 512, I changed FFT. So this is called high FFT. So I changed FFT and went from 2K 2048 to 4K 4096. And if you saw, that caused a little bit of a bump as well, right? In these, in the score. So that's what this high FFT stands for. So I went, and which basically means, you take 4096 samples in that, rather than the 2048 I was using earlier, keeping the hop size the same. Now, one other thing poking around I found, and this corresponds to what, somewhat little bit to what Arto said, I found that you could, so far all these guys had, and I think in 2 lectures back, I went through like the list of random image augmentations, such as Gaussian noise, adding Gaussian noise, flipping the images, adding some other kind of augmentation. There were like a handful, 5 or 6 augmentations that I was using, but all in the image space. But I found that there is I think it's called audio augmentation. I'll take you to that in a minute. once we're done with this, but that's similar to this augmentation thing that for images that a few people had written up, a whole bunch of augmentations that are available. And so what I did was pick a couple of those that I saw other people had used, and I removed the image augmentations, only did the augmentation of the audio, of the clipped audio, not of the entire 60-second audio. Once I create the 5-second windows or clips around the true positive, then I run the augmentation of the couple of augmentations of the actual audio waveform, then convert it to a spectrogram, and my spectrogram is still amplitude, and I still use the 4K FFT. And I tried that, and my score dropped slightly. So I said, well, I mean, that's interesting that this combination of stuff doesn't seem to give me the better results. Actually, the image augmentation gives me better, but well, for kicks, let me try both, meaning I first augment in the audio space, take it to spectrogram, and then augment in the image space. So that's what all aug means, which means I apply a couple of audio augmentations in the raw audio space, then apply a select list randomly of image augmentations, amplitude, high FFT, then 161, still not as good as just basically doing the image augmentations. So that's kind of the bunch of, studies or evaluations I did. Obviously, I would have preferred to have done it with ResNest because those were giving me the best. I was kind of trying to see whether I can get to a 0.9 score with these various tweaks. Maybe I might have gotten there with a ResNest. I still have to try that. But, because these are all just tweaks of the parameters, the various parameters of the basic setup I had. Now, one of the things which I have not done, which is why I was curious, which I definitely want to do, is also see if I can throw in mix-up into this, because I'm doing no mix-up at all as part of any of these. And I've seen, mix-up seems to definitely improve things in this. So that's one. And, obviously doing it with ResNest is another. And the third thing, which I started to do, but I ran out of time. I didn't quite finish it. I have the infrastructure set up to do it. Is one of the things I had seen somebody do was use a bunch of public scores and kind of combine them or ensemble them. So I was like, well, I mean, I'm just going to try and ensemble many of my own runs and see whether that works. So I started work on it, but I haven't finished it. That's something else I hope to finish in the coming week, to where then I might do a few ResNest runs and then try to see whether I get to a 0.9 something score with some combination of these various runs. And then after that will be time to kind of, sorry, go ahead, Arthur.
Yeah, cannot you just take two submission files and average those and use that for ensemble? You just can take all your best submissions, like top 5 submissions, and average those.
That's exactly what I'm trying to do, is get all of these files as input files, all of my submission output files as input files, and then just kind of do some min max average and even some combination alpha, like alpha times x plus 1 minus alpha times y or something, and then submit them to see which of those gives me some results. And it may be I'll throw in even these, because I'm just curious as to having different approaches. Does it help or hurt, or what happens? So that's something I definitely want to try before I move on to more complicated things, because there's a long distance to go, right? Because some of the best results are in the 0.98 kind of space, and
but I guess there is only one result that stands out, right? But the average would be like lower, like average good score. Just let me check it. Okay, no, that's I was mistaken. It like 0.95 is quite. 0.94 is quite popular at the top.
Oh, you mean in the scoring leaderboard scores?
Yeah. I'm just looking at like distribute, like, because like 10th place is already like 0.958, and the winning score is 0.981. Like really. There is like 2% difference between first and 10th place. So I think that's kind of significant for such competition, right?
Yeah, this is 0.98 and 10th is 0.958. Drops quite a bit.
And like around 50th place, it's already 0.92, which is quite close to what you are getting right now. But I guess like being around 50th place is quite a good result, right?
Yeah, but actually, see here, I didn't quite get the last one. Mine is still 0.8. What was it? 0.89. So it's more like, sorry, let me see what my best was. 892.
Yeah.
And not even, it's more like 8926.
Oh, yeah, okay, it's still
like
outside top 100, right?
Yeah. So I was, that's what I was saying. I was trying to get there. I mean, somewhere, I don't know, even here, which would put me in the 100 before I, said, okay, now to get from 100 to the, much better, then I might need to do a whole lot of other things. But let me see whether I can get to here with a bunch of, basic things set up and then tweaking a bunch of parameters, but I'm still at least 30, 40 places off.
Yeah, makes sense. And another thing I'm thinking about, like this someone mentioned in the chat that the difference between cross-validation score and like leaderboard score is quite significant. And also, I think he was like showing those at the last session. He was showing that like probing the leaderboard could give you a quite high score for a baseline just by like figuring out the distribution of the classes in the test set, and like you kind of can incorporate that information into your model, right? By say weighting the classes accordingly. So what we have here is that like or distribution of the labels in the training data is different from the test data, and significantly different, because I think he showed that like weighting, like ordering the predictions by training train data distribution was getting like a really low score, and but ordering with this probing of the leaderboard yielded a good score. So maybe those highest scores kind of incorporate that into the prediction.
Yeah, except you know, the thing I'm curious about is whether you can go. I guess you could probe the test. See, the private data was not available when the competition was actually live, right? Meaning you would only know that by actual submission.
Yeah, but if the private and public leaderboards come from the same distribution, then probably you can like get that. Yeah, let me check how many. Yeah, everyone here had like at the top had like enormous amount of entries. So like the winning had like 170, and the second place 190, and the third place 300. So maybe they were trying to adjust to that, because like they really did a lot of
yeah, I mean, I haven't yet, you know, once I get to, or like once at least many of us get to where we're running out of ideas to get beyond kind of where we are at, then I typically switch to looking at kind of the people who have posted their approaches or their methods they tried for some of the top, you know, pick from the top 50 scores or top 100 scores if they're interested.
Are there any like really high score notebooks public?
I don't know. I mean, that's what I'm saying. I typically don't tend to look at them until I get to, you know, when I say I mean like we collectively run out of ideas, and then, you know, we are kind of like, hey, we have tried everything that we can think of, and okay, people are, you know, running out of new approaches to try, or hey, now that we have struggled with the problem enough, then we know, oh, how did these guys, it resonates more, or it's more useful when we are at that stage to look at some of the top, whoever is or whatever is available of the top set of things. Usually enough people have at least posted about their approaches and about the methods, and even if they haven't implemented them, then, you know, that'll be a good time for us to try to implement, or even go study the techniques or papers that they refer to and such approaches. So that's usually what I've done.
Yeah, I see there are public notebooks with like really high scores, so we could learn from that in the end.
Right. So I tend to wait. I think we are probably a few weeks away from that. Just want to give people, and, you know, Steve has been away as well, and you've been trying different approaches, and, you know, you're already at 0.7. So maybe if you try and then few more, maybe we are at the 0.99 something, and at that point it might be worth looking at, hey, what are all the top things that people have tried, and it would resonate more with us of, oh, I thought of it but didn't pursue, or well, I didn't even think of it, one of the things, for example, on my list, but that's why I said I wanted to push this, because that will be a completely new approach, will require quite a bit of work, probably, is the whole, there's a whole set of data that we have not used, right, is an approach of contrastive learning. And I've seen some references in my browsing of, just like you said, with vision transformers, of contrastive learning applied to audio. And, the reason why that's interesting is because we do have this data of false positives, right? So which none of us have used so far. So that would be interesting to try with a contrastive approach, saying, here's the true positive, here's some false positive. How do I set up the contrastive approach to benefit from and learn, and whether that gives us any better results than what I've, than the things we've tried, traditional, straightforward approaches. So, but that's why I just wanted to push this to see where I could get before I switched fundamentally. And the other thing, which is more of my personal drawback, is I haven't tried anything in TensorFlow, and also TensorFlow combined with running on TPUs, which there are several standard notebooks, but I haven't yet gone down the path there to even try, partly because I'm not as familiar with TensorFlow, and secondly, the TPU usage and stuff I'm even less familiar with. So I kind of get lost on, okay, what is being done, rather than just copying it. And so that's another kind of energy barrier I have to cross. And that will also be, I think, helpful, because I've seen some good, again, I'm not talking top results. I'm just talking, okay, how do I set up an infrastructure basically and get things working, but use TPUs, for example, and therefore be able to run more experiments or try different things. So that's something else I'd like to try too, which I haven't done yet, or any of us, if people are more familiar with TensorFlow and TPU usage, and Steve has definitely done some things with TPU, so he might be somebody who might be able to try that as well. And this contrastive thing is something on my list, but for that I would need to obviously switch approaches and try that. And before that, like you said, even with the current approach, a few more things I want to try. Maybe I'll cap out at close to 0.9, which is fine. It got me to the, like you said, 0.9 is probably in the top 100, whereas I'm still at 0.892, which puts me at 130. Whereas the 100 is at 0.900010. So that would be an interesting thing to get to. If I can get mix up, maybe try the transformer things and stuff like that, right? Because again, some of these, though, they've gotten to good scores. Like you see the 45, this guy at 38 with not too many submissions, like 43, 6489. Yeah, some of these are 324, but look at this guy, it's like 14th with just 37. Some notebooks I saw here, which again I haven't yet pursued. I have also used student-teacher kind of methods or distillation methods, which, given what we're learning in deep learning, the NYU thing would also be interesting to try.
Yeah, that's one like really interesting topic. How do you like utilize that self-distillation stuff?
Yeah, knowledge distillation, and using a teacher network to train a student network, and then using that student network to predict. So that's kind of where I'm at, but I just wanted to also try this ensembling because it helps, like you said, to just set up the infrastructure to be able to run those kind of stuff and quickly and see where it gets me. So that's something I'd like to do, and then change it to REST Nest. And to your thing, I want to kind of look at maybe using vision transformers, if that's an easy enough switch, and see where that gets me, whether it gets me close to 0.90, and then time to try a whole bunch of completely different techniques maybe.
Yeah, Team library also has vision transformers, I think. So that's
which library? Sorry,
Team. This TIMM, okay. Which I think Steve mentioned it in the chat with you about REST Nest.
Yeah, that's the one I want to go get REST Nest from as well. So that's kind of what I was playing with and getting to the results of. Yuri, did you listen to the San Diego guys? And I haven't yet listened to them because I didn't want to kind of, like I said, I want to kind of save here are a bunch of new techniques to get the top score. But did their talk kind of was its stage, or what did you take away? I mean, did they cover a whole bunch of things that you could try, or?
We're asking about the review from the other study group?
Yeah, the video, I think.
Yeah, the posted San Diego. Yes, San Diego Machine Learning Group.
Right.
Yeah, watch it. I need to watch it again. It's I think you already probably have better idea from but they I don't know. I need to watch it again. They sort of analyzed the types of techniques people use, how to separate data. They talked about so I think we're probably at the level. I don't know if that's something new compared to what we discussed already. But yeah, I haven't rewatched it. And
I'll probably go watch.
Yeah. And there are a couple of things. Go ahead. Sorry.
Go ahead. Finish your thought.
Oh no! There was one thing I wanted to try, but I didn't have time this week. I was busy at work. So
the one question that I haven't. One comment and then a question. The comment I have, at least last week, I found out one particular detail which was bugging me the week before, and I'll make the statement. And if that's at least my current understanding. If any of you come across something which seems to conflict with what I'm saying, I'd love to hear it, because this is my own conclusion from the various digging I've done. But one of the things that puzzled me, or at least, I guess the best way to say it is, it puzzled me also as an open question, is the number of MELs, the N MELs, right? Which again, going back to what Arto had pointed to, the guy who had done the ResNet 18 or 34 study, and he said, I'm finding a good score as I vary N MELs, and N MELs of 128. And originally, at least, maybe I should state the conclusion and then go backwards. The conclusion I came to is that, interestingly, Librosa at least, and I would assume that the other audio things, libraries are similar to it. When you create a spectrogram from the from the raw audio, you give it like the sampling rate, the Fmin, Fmax. Interestingly, there's nothing about nmels that you mentioned there. So I was like, okay, so what is the nmels you're getting when we go through this process? And interestingly, if you follow the link from the spectrogram generation itself, then in Librosa, it points you to kind of like a, what, for lack of a better word, I'll say a subsidiary function that the MEL spectrogram generation thing uses, which uses a default nmels of 128. And so in effect, if you just use the, sampling rate, blah, 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 and you just use the standard setup in Librosa to generate your spectrograms, the spectrograms you're getting are with nmels of 128. Now, the reason I bring this up is originally my thinking was that your specification of FFT, hop, window size in time or stuff determined your nmels, but it turns out that that's not correct. The nmels is an independent variable that you get to choose. And that's the conclusion that at least I came to. If you guys come to or understand it differently, I'd love to hear back to either fix my understanding or confirm it. Because I was puzzled by, if I fix the NFFT and the hop and the like the window chop, like 5 seconds or 10 seconds, which again, you can convert to the number of samples, given that you have the sampling rate. Does that fix my number of mels? And the answer is no, that doesn't inherently fix your nmels. You can specify the nmels, but you don't get to specify directly in that equation. You have to go somewhere, to the next level and specify there. And then when Librosa uses that setup as part of this converting spectrogram, then it changes the number of mels. But if you have a different understanding, or then please feel free to correct me, because that is at least my understanding currently from all my digging. And the reason why this is relevant is because it matters, as one of the parameters that can be changed to improve your results from the link or the weights and biases sweep of hyperparameters. So that's why I dug into it, and at least that's my conclusion right now. So if my understanding is incorrect, let me know. Which leads me to this other.
From the video, judging from the videos by this YouTube guy Valerio Valerado, So I just understood that nmels is like independent parameter, and you can set it like as you wish, and basically it's like inspired by human perception, right? So
right.
So that would be like maybe some settings of nmels doesn't make, like some combinations of setting nmels and FFT doesn't make sense because you don't have enough frequencies to like bin this. Basically, as I understood that this nmels, it makes like logarithmic discretization of the frequencies, right?
Yes, of your plot of your MEL spectrogram. That's why it's a MEL spectrogram versus just a spectrogram.
Yeah. So basically, if you have like your NFFT low, it probably wouldn't work with like high nmels, right? But if you have high NFFT and and then you can increase your nmals. So there is kind of connection, but like you set this two parameters separately.
Right. Yeah, there is I mean, ultimately they are linked because you're going to frequency, and then the frequency and how you split it into MEL frequencies, obviously the two are related, right? So there is a relationship there. I don't mean to imply no relationship, but what I meant is you don't, by determining NFFT, hop, and window size and stuff, you don't determine the number of MELs. You can independently choose that, which is what you're confirming as well.
Yeah, that's my understanding too.
Right. Now, that's the comment part. The question part is this. Question part is one of the things which I found, and I haven't yet in my brain linked and established the connection or lack thereof, is between the size of the image and the rest of the parameters that you choose, and how that is dependent and what impact that would have on the ability of your ResNets and DenseNets and stuff to figure out the spectrogram. So by that I mean, like my current infrastructure, I just resize the image to 200 by 400 pixels, 200 height, 400 width. Now, question is, if the couple of questions. One is, in that reference thing that he talks about, when I say he, mean the weights and biases thing, he never touches on the size of the image that he is using. I haven't dug into, his code, just reading the, that's something I have to do, listed to do, probably will do this week, dug into his code to see what size of the image he uses. But the curiosity I have is, does the size of the image matter?
Yeah.
And how is that related? Go ahead.
Yeah, like one intuition I have that increasing nmals and then resizing the image to something smaller than nmals doesn't make really much sense, because we will lose that information, right? So basically the
Correct.
output, the MEL spectrogram is with height of nmals, and the length determined by the other parameters like your window size and length of the time interval you choose, and hop length and all that stuff, right? And basically, when you resize image in the vertical direction, you kind of I don't know. I just wouldn't resize it at all. We have like nmals, and that determines the height of the image, and maybe resizing in the horizontal dimension makes a bit more sense, but I'm not so sure about that too, because basically you can control the size of the image by choosing your spectrogram parameters, right? And then when you resize the image, you just do something with it, which involves some kind of interpolation or something like that.
Which is, I guess, my question, and I wanted to play with it, which is to say, what is the shape of the spectrogram when I don't resize at all? What does it give me? I mean, like you said, obviously does it just give me a 128 on the Y because that's the number of MELs, log MELs, or whatever on the spectrogram plot? And, if I take a chunk of 5-second clip, then is the x-axis pixels correspond to some functions to the 5-second clip? And if so, why even change it? And do I lose something? To your point, I'm not losing anything on the Y dimension if my height is 200, because that's greater than the number of NMLs 128, right? But I do, or it's 400 is, and obviously that correlation or that intuition is what I currently lack. And I was just wondering if anybody had it, or, can anybody think of, like you said, my intuition was just to remove the sizing and then see what is the shape of the spectrogram I get, and then see whether any impact is there because of the change in the dimensions, or there is none.
Yeah, so I was I have here, what would be 1 second of sound if you convert it to MEL spectrogram, and the first dimension would
What's your sampling rate?
So the sampling rate is the original sampling rates are 48,000, and then I use an A50 4096 and top lens 512, and the window lens would be, I think, by default the same as NA50, right?
NA50, right? Yes.
And 1 second with those parameters, 1 second of audio results in 94 for the width. So if you take 5 second span, it would be 480 in width with these parameters. But yeah, I think you had something, but yeah, it's a really you can look at that and see if your image, if your spectrogram gets compressed in the Y, in the vertical or horizontal plane or not, if you do it with 5 seconds. And basically by changing from 10 second pieces to 5 second pieces, you changed how your how your image compression works, right? Because maybe 10 seconds was more than 224, and 5 seconds is less, or it's not it's twice shorter, right? And basically it affects the resolution you or interaction you have when rescaling this image or reshaping it.
Yeah, and my height width is, I think I have to double check, but about 200 by 400, I think. So, or 220 by 400. So 220 should cover the Y, like we discussed, for 128 mLs, or even if you go, unless you go to 256 mLs or something. And right now, as I said,
but
the
it
default
also
is
doesn't make
128.
sense to upscale or make it larger, this Y-axis, right? Because you don't add any information, you just stretch it.
Yeah.
But and I don't think that they can improve performance, right? Because you should have ideally the same pattern, and if the pattern is changed somehow, it's probably distortion, not an improvement.
Yeah. So what if the Y you get, you said 94 on width, what's the Y?
So the Y is 128, that's number of mLs.
Oh.
And And yeah, so I didn't change it. It's a default value. But in experiments, I was using the like full audios converted into a spectrogram. So my spectrograms were really wide. So that's.
Yeah, so it would be 128 by 60 times 94.
Yeah. Maybe I changed the parameters there a bit to make it shorter. I guess maybe I decreased the NA50. I'm not sure. I got to check it. Oh yeah,
Okay.
I changed the window length. So I set the window length to be 2000 to 2205. Yeah, I guess I just took those best parameters from that report we mentioned, and yeah, but like another thing which is interesting here, I guess, is how do these parameters which worked best for ResNet 18, how do they work for larger networks? Maybe it will be different, right?
Yeah, except I think that's where, if I recall correctly, and I'm talking from memory, so I might be wrong, but I think he said that DenseNet 161 also was very similar to what he got with ResNet, whatever he was running, which is the reason I chose DenseNet 161 to try first with the set of parameters I had, which are kind of close because my NF50 is 4096, my number of MELs is 128. I forget, his hop was somewhat less, I think, mine is 512, but his was like 380 or some odd number like that. You know, so in the ballpark, not precisely the same, and I got kind of close to the same results with DenseNet 161 as I got with ResNet 50. So, but yeah, thanks. I think the conversation helped in trying to firm up the relations of the pixel size, and I was wondering about why the resizing is done and how I can kind of stick to the resolution that would be best to get the 5 or the 10 seconds. And obviously, yeah, the, you know, that may be one explanation of the improvement in score I get from 10 to 5 too, right?
Yeah, because it's like everything is interconnected here.
Yeah, yeah. And
if
because the resolution
image is definitely like changes in things.
Right. And if, you know, I'm sticking with the resize, but then I reduce the window, then there are more informative pixels rather than stretched out pixels on the along the x-axis, right?
Yeah. Also, another thing that just came to my mind, you know, that progressive upscaling or resize, like when you train on smaller images and then upscale. So maybe it would work here too. We could like start with some small animals and then increase it and use the same network, but try to utilize this like higher resolution features. I wonder if that would work.
Yeah, in fact, I was thinking of that in your context of using it for the entire window size, right?
Yeah.
Meaning training it on a, you know, particular window size and then growing that.
Yeah, that also should probably work, but also like to make it work, like you get to I don't know, probably anyway switch to this like fully convolutional variant, I guess. But on the other hand, yeah, I got that 72 or something on the leaderboard with just a single ResNet 18 trained in this like very naive way. and that's not that without cross-validation and ensembling, right? All your scores is like ensembling, right, of 5 models.
Yes, 5-fold. Yeah, 5-fold. Yes.
And
Yeah.
I just like it would, but on the other hand, because I'm using this Meetup, and I'm training for like 40 epochs with Meetup, it takes like quite a bit of time. So I like
mine is 20 epochs training only, but as we saw, that itself, that's good enough, because doubling it doesn't help, and there's already overfitting. So that's why I think Meetup is very.
If you add Meetup, you can train. Like got to train for longer, I guess.
Yeah.
For example, in
absolutely.
that Jeremy Howard's book, I think that they were talking about images, but they suggested like some really a lot of epochs to check the benefit of Meetup. They in the book there was like exercise that suggested like try to train your network for, I don't remember really what was the number of epochs, but something around maybe 80 or something. And I guess because like Meetup is such a I don't know, hard to grasp augmentation, it might require like a bit more of training to be useful. But on the other hand, if we use this low value for Meetup, like 0.1 as I'm using, and I don't know, so I saw the best results with 0.1, and this guy also reported that he got really good results only with 0.1, not with the higher values. And another thing that was puzzling for me, he had like this Meetup value from 0.1 to 0.9, and 0.1 was performing like really well, but 0.9 wasn't. And so that's what I don't really understand, because isn't it supposed to be like symmetrical? You take one image and
I was thinking the same thing. Yeah, no, that I was thinking the same thing when you said 0.1, then I would imagine 0.9 to be, but I haven't read. It's been a long time since I looked at Meetup, so I was like, okay, something is funny, and I really need to understand why that is not the case. So you are saying you're observing that is not the case, meaning it's not symmetric. 0.1 of something plus, 0.9 of something else doesn't work out to be the same, or 0.9 of something plus 0.1 of something else.
Yeah, but that's judging from his report. I haven't done these experiments, and maybe that's just a random variation, right? It could be that's but he has like really I think multiple runs for each setting, and he has those error bars and everything. So I just don't have an explanation for that right now.
Okay. Yeah, it's been a while since I looked at the Meetup paper to venture an opinion on it. So I'll have to go read it to see whether that makes sense.
Yeah, maybe it is related to like some particular implementation or something. Like I don't know, but like
let me try this. Meetup is basically saying I'm going to take some other random image and then combine it with the current image, right? And then also use the two labels, if I recall. Is that true, what I'm saying?
Yeah. Basically, you take some percentage, like linear combination of two images and linear combination of two labels.
but then doesn't it make sense that if you are expecting, let's say you do 0.1, and again, I'm assuming 0.1 would mean 0.1 of the other guy and 90% of the current guy. And if that's the case, I mean, I'm again assuming that's the case, then you're just softening by mix-up like the absolute confidence, so it doesn't become like a one hot, but a little, as they say, smear the rest of the probability mass, so it's all not on just the one hot current label, and make it smoother. But then if you flip it, where you use, instead of 90% of the current label, you use 10% of the current label and 90% of the other guy, then obviously you wouldn't expect the same result, right? Because you don't want it to have the same, it shouldn't work as well for predicting the current label correctly.
Yeah, but I don't know. Yeah, I think I got to look at the mix-up paper and code. But I guess you take both image and label in the same percentage, right? So that what makes intuitive sense to me. If you take say 90% of image A, then you got to take 90% of label A, right? And if you take and that would make it symmetrical, right? Because it doesn't make difference if you say, okay, this is my image A and I take 90% of it, and this is my image B, I take 10% of it, or if you change it and say this is my image B, I take 90%, and I don't know. Yeah, but I guess I got to look at the code and see if it's how it really works.
Yeah, exactly. I haven't done that, so I think both need to look up the. And is this same as or different from label smoothing?
So yeah, it's different because in label smoothing you just distribute the probability across all the weights uniformly, so all the labels uniformly. But in mix-up, you basically want to really predict this particular two labels, right? And if you have a lot of classes, then you will. Your network should learn really to predict the two images you combined in the proportion, but it shouldn't predict all the other n-2 images. And in label smoothing, we just say don't put too much weight on anything. Be always a bit unsure.
Softer and less sure.
Yeah.
Okay. Yeah, I wanted to kind of dig into not just mix-up, but use that to also dig into label smoothing and understand the differences. So that would be good. At least I will follow up on that this week.
Yeah, but label smoothing also could work maybe in our case too. And yeah, it would be really interesting to compare because I was using Mixup, but I wasn't using any other augmentations, and just adding some noise and maybe some other spectrogram specific augmentations. Maybe it could just do the same as Mixup does, for reducing this overfitting and getting the same score.
Interesting.
Yeah.
Definitely a few more ideas to try before we.
Yeah, and if I remember correctly, in the courses couple of years probably ago when the mix-up was introduced, so Jeremy Howard said that he views this mix-up like it has potential to become one augmentation to rule them all. You know, if you use Meetup, you just don't need anything else.
Yeah,
But
yeah, I remember. But it's not turned out to be, well, I don't know that because people have moved on to so many other things that I don't know whether that's, and he was obviously talking in a ImageNet kind of context, right?
yeah, but now everything is moving like to like this self-supervised learning and other things,
Yeah.
and maybe we like don't. Yeah, so this field is so highly empirical that like you don't know before you don't try it.
Try. Yep. That's one thing about this whole field, that the simplest answer when you ask somebody is like, try it.
Yeah, and I was looking at Meetup. There is a paper called Meetup Transformers, and it like introduced a way to use Meetup for language modeling in transformers or language applications, not language modeling per se. But it came out like some time ago, and I haven't seen it like getting any attention or much attention. Yeah, I think I'm thinking of trying it because it should be like really simple to implement, and they essentially like mix up the output of the transformer before the like some classification head or whatever you have, and yeah, just do it that way. But I don't know. It like they reported some improvement over like BERT, but BERT is so far from the top performances we have now that I don't know if like I think it's a kind of bad habit of the researchers to report the results on BERT because like there are like literally hundreds of things that improve over BERT, and you add another like things that can improve over BERT, but yeah, like you really got to improve over something more performant, right?
I think so. What is the latest on that? Is it Distilbert? Is it like, I mean, Distilbert is more the simpler version, but like the most SOA state of the art on, I haven't looked at it in at least 6 months or so, which is.
Well, at least you have like Roberta, which is the same as BERT, but trained on a lot more data. That is one thing that performs like strictly better than
Deberta was
BERT.
another one that was coming out from Microsoft, right? Deberta, if I remember correctly.
Yeah. So this Deberta, it's a bit different from BERT. So it has some like architectural innovations, and it also performs better than BERT. Also, there is Electra, which is trained in a different manner. Like there is some kind of generative adversarial training style thing, and it performs better also. Like it's close to state of the art, but actually like actual state of the art is not very interesting because those are just huge models, and you probably cannot use those. But like still, like the original BERT was just basically all the new models kind of very similar to the original BERT, but there are like a lot of improvements over that, and like if you are thinking of using BERT, just go into Roberta is always a good idea. I think it has like larger size of the vocabulary, so it uses like some more memory, but that's not as important as the performance gain. So, yeah, and
Okay, cool. Thanks
By the way,
for joining.
I had to step up, and since you guys discussing new networks, did you guys see the Fourier transform paper? So Google came out with a new paper where basically they're saying instead of using transformers, they actually use Fourier transform layers, and that achieved like 92 to 98 performance of BERT of transformers, but with like with like huge reduction of speed or increase of speed.
oh, I haven't saw
Yeah,
that.
I saw that
sounds
yesterday
super interesting.
in somebody's post, but I haven't followed up on it. So
It's still maybe like research. It was a research kind of publication, but who knows? Maybe Google is already like implementing it.
Thank you. That's really something. Sounds like an interesting thing. I would love to see what they came up with. Sounds really interesting.
okay, cool.
Yeah,
It's about 11:30 or 40. So thanks everybody for joining, and we'll meet again next week. Hopefully, we'll have more interesting results to share on, and at least few of us would have touched 0.9 or increased our scores from where we are at right now. Thanks for joining. See you all next week.
Thank you.
Bye.